Hey, welcome to a new episode of the SDV Coffee Talk, a very special one because SDV Coffee Talk turned to 2 years, actually. It's 2 years old now. This is this
Happy
episode, so to say.
birthday!
Yeah, thank you so
Congratulations.
much. And we have now again, amazing round of guests. We did the first episode, I think, 2 months ago about partnerships in SDV. And now we would like to continue this topic. We could not complete at that time. It was a very interesting discussion. And after a short intro, I would say we can start. Just a short disclaimer from my side. Everything what I say is my own opinion here, and has nothing to do with my employer. Yeah, let's go. Marcus, do you want to start the introduction?
I can do it. Thanks, Fatih. My name is Marcus. I'm working for Vector since a little bit more than 10 years, and I'm heading the sales and business development department for all embedded software topics. Thank you again for inviting me.
Partha, thanks. Partha?
Yes. Thank you. So this is Partha Goswami, originally from GM. I have been an independent consultant advisor for the last 3 years. I also speak and write at different events. The focus is basically case, connectivity, autonomous software services, and electrification, and out of which a software-defined vehicle or SDV has been a very key focus of mine. And I have collaborated with some of the speakers here in past on different reports, and I continue to do so at this time.
Thanks, Partha. Brian?
Yes, hi. Brian Carlson, Clear Catalyst Consulting. I have previously, as a decade or so, at NXP Semiconductors, Global Marketing Director across automotive processors. So I bring that semiconductor experience. And now I'm helping companies grow their businesses. And one of my clients is SDVerse. So SDVerse, the software marketplace. So we're really driving momentum there to connect buyers and sellers of software and services for SDV. So I'm still heavily involved in SDV. Historically based on silicon semiconductors partnerships and building all that up, and now on the software side of how you speed up go to market for SDVs with a software marketplace.
Thanks, Brian. And my co-host Florian.
Yeah, you're not introducing yourself, Fatih, so I don't know why I have to introduce myself every 4 weeks.
Go ahead.
Yeah, okay. So I'm in the automotive industry for 20 plus, actually 21 plus years by now. Been at Continental, Tesla, NIO, and as a consultant around everything vehicle now for the last 6 years, and the co-host of this for almost 2 years.
Exactly. So thanks for the introduction. Let's recap. Have the recap from last session. 2 months ago, we started the conversation with partnerships and SDV. Why partnerships are important in context of this SDV topic and in the development, how OEMs should use partnerships as a strategic way to develop. And the conversation was really interesting and very, very deep. And I think we can connect to this and then start with the first thoughts about, SDV is very much connected to semiconductors because you have a lot of software running on silicon. Mm-hmm. And I think the semiconductor sector is quite important here. Yeah. And probably we can start with some thought about that. What does it mean actually? Now, how OEM should work with semiconductor in partnerships. For example, I've read somewhere once Tesla was starting building their own chip silicon, so to say. But this is a different way. Mm-hmm. Should the legacy OEMs go this way, or should they probably build up some partnerships with existing silicon vendors? Like
before we dive in, this is how it traditionally looks like, right? So you have an OEM. The OEM is sourcing some tier one. They give them requirement specifications and so on. And the tier one is then going out and is sourcing the hardware for the ECUs and is writing the software and so on. And then maybe there's a tier two or even tier three involved, and they are providing the silicon into that chain. So now, and then I'm happy to hand over to Brian because let's go into today. Now suddenly everybody's talking to each other.
That's exactly right. I started in 2016 and seeing this happening, right, where mainly the customer who actually bought the silicon was your tier one, and tier one delivered boxes. And as we know, SDV turns it on its head, and it's a collaborative model between everyone in the ecosystem. But I would say that we talk about architectures, we talk about zonal architectures a lot, we talk about software a lot, and I think the thing that brings that all together, right, to actually make it happen and to actually host the software to make it safe and secure is the silicon. So it really is, I call it the foundation layer. It's central to all of this. And effectively, the semiconductor vendor engages with the OEM very, very early on, right? I call it the first strategic partner with the OEM a lot of times now. Traditionally it's through the tier one, but a lot of times the OEMs are engaging first because they're looking at architectures and driving architectures and then working with that whole ecosystem to build it out. So I say, it's central to the SDV strategy, and it's really foundational for the SDV partnership. So everything we talked about, the last session about partnerships, we focus a little bit more, I think, on tier ones or OEMs and tier ones. This is kind of at the bottom layer of how this all comes together and create this floor to build your SDV upon. And it really drives partnerships, has a huge impact on other partnerships because certain semiconductors have certain types of partners that bring different value to the OEMs. So I guess that's a quick intro of why it's important, that it's central and it drives everything on top of it, and it provides the baseline foundation for safety and security and how you actually isolate software and how software communicates to other software. It really, and we can dive into those things as people are interested or want to have questions, but that's the baseline, I would say, introduction of why it's really important from that perspective.
Yeah. Fatih mentioned, starting, you mentioned legacy OEMs, how they might be handling this situation, right? So I think legacy OEMs in many cases have been looking at, Tesla. To start with Tesla, they've been looking at that and they see that, hey, Tesla has completely, vertically integrated, including its own chip design. And I think that's kind of something of big interest to them. Of course, other companies like Rivian has been doing the same right now. But I think for legacy OEMs, the one that I come from, for example, I think the issues are slightly different. I actually did a project maybe around 2016, almost 10 years back, to look at this question: should OEMs be engaging in development? Basically, we came at three big issues. One is the skill sets, very unique skill sets you need to have to develop this in-house. Second is the cost, and the third is commitment. You can't just say, oh, I want to do this and start something, and after 2 years you realize, boy, I really can't handle it, and then kind of go away. But there is a fourth factor that I have come to appreciate, which is flexibility. You can start developing your own chipset in-house, like Tesla does now, like Rivian is doing, like few other companies in China are doing. But then you have to make sure that you are ready to do everything your own way and continue to do that like that, right? For legacy companies, if you do it this way, you do lose some flexibility, which you may otherwise have when you are working with multiple suppliers, the way you are set up right now. So it's an issue about control, which you will have if you have your own chipsets and everything flows from there, or you have to be ready for the fact that you will lose some flexibility in the process.
Also, you certainly cannot blame anyone if the supply chain breaks off, right? So OEMs really like to have somebody they can point a financial finger on.
Yeah. Yep.
Yeah, it's a much bigger amount of effort and cost. And you talked about cost. And if you look at where these processes are going, even the microcontrollers are down to 16 nanometer. Now the next step up is 5, and then the leading edge typically is at 3 nanometer. Those are very, very costly ventures, right? And the cost is tremendous. And if you're a Qualcomm or an NXP or an Infineon, STDs type, right, you can amortize that tremendous cost, right? I saw costs go from over the last 2 decades from 30 million to 50, 150. Now we're talking $500 million or $500 million to $1 billion to develop these chips, and it doesn't make sense a lot of times to do that. And maybe in very special cases, like Tesla, for example, if you want to control your ADAS and your autonomous driving, right? That's the motivation there, but not the general processing that you're going to put in other parts of the vehicle necessarily. But the cost is tremendous, and it's only going up exponential. So that's a big issue.
Yeah.
So just one quick
now you
thought
have to
before
add.
we give Marcus the word. So Tesla did what they did for two reasons. One of them was because they couldn't find a cutting edge chip in mass production in the market they wanted at that point. That's number one. Number two, and that's what Partha always said, they also had the skill set. So they had the people inside and say, I can design it and I can manufacture it. So those two together, a very rare combination. And that's why they actually pushed into that direction. All right, Marcus, do you have a voice?
Yeah, I'm really trying to figure out where to start because let's say from the perspective of a software middleware software ecosystem provider, our view is slightly different, I would say. So and last time we were let's say super harmonic. So let's break up with this. And Brian, you can punch me then in the face next time.
No, this is where I think this will be interesting because we definitely want from a software perspective versus semiconductor and how they come together. So that's what we want to do here. Exactly. Yeah.
Exactly. And I mean, I would a little provocative statement. I would say right now, let's say hardware is getting in the focus because nobody wants to care about it in the future. So
right. They talk about decoupling, right?
I like that statement, Fatih. Write that down.
Exactly. I mean, this is one of the main features in my understanding of the SDV, trying to decouple the software side and the hardware side. So of course, you need at the beginning a very deep integration of the hardware, but it needs to be a little differently integrated because in the end, you need to be able to either simply switch chips or extend it with different chips. And in the end, the software developer actually doesn't really care about the chip because this is what we see in the current development environment. Everything is virtualized. So at least none of our software developers at the moment, none is wrong, but only very few still have hardware on their desks, right? They're all using it in a virtual simulation environment and develop the software. And of course, there is hill testing later on, but the whole system in the end you should not be really aware of the hardware where the system is in the end running on.
And I totally understand. That's why it's interesting. So yeah, if you're a software developer, that's the ultimate goal, right? I don't care, but ultimately someone has to care because the platform decision is the foundation for your functional safety. It is the platform for your security. It is the platform of how you communicate seamlessly under the covers. The software guys may not care, but someone has to care of how data moves efficiently in the lowest latency with the highest security and support ASIL-D. But there's quite a lot of things that are, I believe, overlooked from the software perspective. Everyone thinks, okay, we decouple hardware, software, it becomes an easy task. It's not. Yeah. It's a totally different world. That's why I really wanted to push this topic at this session to kind of give a little look at why there's so much on the covers that I don't know if people just, they don't realize or that's not their world. And that there's quite a lot of stuff that has to go on below the covers to make it a seamless, decoupled environment of what you're talking about. So I understand where you're coming from. That's the goal from a software perspective, but there's a whole nother world that you have to be doing in parallel. It's code development. It's early on development before the software even, right?
But as far as
right, I'm just saying this is the ultimate goal, right? And I mean, achieving this, of course, is a lot of work. I mean, this is the reason why we are here, right? If it would be that simple, we just would be done.
I mean, as far as I know, Vector is also partnering with some silicon vendors, right?
Yes, of course. I mean, we have many partnerships with silicon vendors. And
what is the purpose actually in this? I mean, you usually provide as Vector tooling, right? And what is the goal actually partnering with silicon vendors? What do you achieve? What do you want to achieve with that?
There are so many different goals. I mean, I try to keep it short. So let's say maybe starting with the group of microcontroller semiconductors or by the class of microcontrollers, because it's a little bit different to the ones with the microprocessors. So on the microcontroller side, it's typically on how to efficient in a most efficient way integrate the drivers and even cooperate on the MCALs. So usually in the past, we have developed our own drivers, semiconductors have developed their drivers, and now, I mean, mostly also for cost reasons, we're now combining. So we are putting our features in the stacks of the semiconductors and trying to then provide a better offer. Also, usually we take the feedback we get from our customers from the market and bring it to the semiconductors to influence the chip design for the next generations. So if we figure out, okay, this and this when the zonal controller started at the beginning, and everyone who did like a zonal controller in maybe like 5 years ago, there wasn't really a good chip available there. So every chip has had some flaws. Either you had too less IOs, too much IOs, memory was not fitting. So these kinds of feedback we feedback to the conductors, and then try to also optimize the chip design.
I mean, regarding
on that point, I'd like to just mention, I was going to talk about that, is that there's SDV ready silicon, which is very different than what I'm glad he mentioned that, because it's true, right? We had to go through a whole transition in the 2016, just pre-COVID type area, right? In that area where you become SDV ready silicon, which is very, very different than a traditional MCU or a traditional micro processor design. And so this is what I was talking about, is that it drives compute memory IO requirements beyond the classic MCUs, right? There's so much more involved under the covers now, and a key part of that is the isolation of how do you integrate multiple ECU or multiple functions, at least within a single chip, right? That's where everything's going. These zones could have 24 different ECUs inside a single chip now. We've shown that when I was at NXP, but that takes a very, very different type of silicon. Think about if I'm running multiple ECUs at the same time, or think of functions, what if one goes down? What if it has an error? You have to run, fault, you have to be not fail safe, but fail operational, and you need to be able to recover from it. And you need hardware that ensures that. And there's a lot of complexity, like I was saying, on the covers, but it leads to that, is that you're right. It's what I call SDV ready silicon is very different than traditional silicon that we've had in the past.
But regarding this topic, Brian, I mean, why don't we have off-the-shelf hardware here, silicon? Why we have to invent always, things in automotive, new processor? Why? And why we can just use off-the-shelf stuff?
These are off. The ones I'm talking about are off the shelf. You can go to distributors and buy chips off the shelf from us, from Qualcomm.
But I hear so often from OEMs they develop everything from scratch with and the PCB and then the ECU. I mean the whole hardware is actually developed from scratch for every project.
And that's the thing. You don't need to do that necessarily as much going forward, right? Because you're not building a special PCB and hardware for every function. They're all different. So this is a big advantage of SDV. Not only because now you're limiting all the wires, because we're seeing traditionally 25-30% reduction in the wires, but now you can develop a hardware that could be reused and dynamically allocated workloads within the zone or within central compute, and you don't have to have 100 different 50 different 100 different PCBs and boxes and all the supply chain around those. You can have a few key ones and leverage those, and this is where that integration comes into play that makes this a much more complicated problem on the hardware side that you have to deal with, and you have to have SDV ready silicon, whether it's in a zone or whether it's in central compute.
Yeah, but and I was going to say that maybe OEM is trying to develop its own custom chip, okay, and then it may want to buy non-off-the-shelf components and parts from NXP or whoever. But if you look at companies like NVIDIA or Qualcomm or even Mobileye, right? I mean, they are essentially providing a common platform, maybe with minor adjustments, to their OEM customers. So NVIDIA is offering Hyperion, for example, right? It's now adopted by multiple OEMs, and I'm sure they are slightly different in some sense, but essentially is the same design. Qualcomm has what is it called? The ride chassis, right? The ride chassis, which is their main common platform. So they basically, even though they have like a low end and a high end version, but essentially the core design is the same. Maybe they have more memory and things like that, but they have standardized, and it is actually off the shelf in that sense.
Yeah, I see three buckets. I typically group these semiconductor companies into three buckets. There's kind of the complete stack, complete thing that like an NVIDIA or Qualcomm. In the middle camp, I call it more integration, the integration and enabler. They do a lot of pre-integration, whether it's NXP, Infineon, Renesas, and then others that I call more enablers. If you look at their offering, they're more SDKs and libraries and maybe some of this other, but not as much as some of these others. And those are like ST, TI maybe are more along those lines as more of an enabler. So you have enablers, integration, and complete stack type of. So every silicon vendor, I guess they kind of fit within these things, within these kind of buckets of how far they take it, right? And typically the ones on the left are the ADAS, the full stack is more, the ADAS infotainment types of things. And the ones in the middle are a lot of the central compute that are not the ADAS infotainment, the real-time vehicle central compute. And then the other ones are more at the edges. So there's a lot of different ways to slice and dice, but they do kind of fall in these types of buckets.
Yeah, and I think the nature of specific partnership or collaboration or JV, whatever whatever it is there, may also vary based on what exactly you are trying to do. For example, in your case, Brian, correct me if I'm wrong, with NXP, some of the partnerships are actually about developing the architecture, not necessarily selling a package itself. In some cases, you might be offering just the reference design to your partners or customers. So I think not everybody is basically buying or procuring the chips or the platform in the same way that than the other one, for example. Is that correct?
It varies by OEM, it varies by semiconductor. So it's not like
that's
a
what I'm saying.
fits all model.
Yeah.
And a lot of the integration really, and speaking, again, I'm not at NXP, I was at NXP, just to be clear on that. So I can't speak, I'm not speaking on their path really, but giving some insights of my view. But a lot of the focus there was on pre-integration, and people like Vector, people like EB and others, right? If you pre-integrate with those platforms, like I said, it's like the foundation. If you can get that all in place, and there's actually a lot of underlying software that we haven't even talked about in these chips that's more at a system level that manages this, which is not AUTOSAR. It's totally secure. It's totally independent of all the chips or all the processors on there that manages things, that the security and isolation, there's quite a lot of stuff that goes on under the covers. That's part of that foundation. And then you start to layer on the RTOS, or the AUTOSAR, the hypervisors, and all that stuff gets layered on. And then you have middleware, and you're seeing some of these acquisitions, like the acquisition of TT Tech Auto there that was brought in for some of the safety stuff. So you start to get these layers that get pre-integrated, whether it's within the semiconductor vendor, right? Semiconductor vendors are not just providing chips anymore. They're providing, like I was saying, they're providing a lot more, all the way to a total stack. But so the level of integration is what's really different there. How far do you go in those stacks? But the whole idea is that you're helping the OEMs and tier ones move faster, so they don't have to going towards Marcus's and the industry's dream of separating hardware and software, so you can just write applications that work. You don't have to know all those layers underneath, and it's all abstracted to a software developer. That's what all these pieces are doing. They just build upon each other until you get to that level.
Yeah, and I think we are forced to do this. I mean, this is exactly right. This increase the level of integration or pre-integration, which is outside of the project, because I mean, you cannot do it in the project anymore. Stuff is really getting complicated, and the expectation is actually time-wise, it's even shrinking. It's not like a 3 years or 4 years cycle for sometimes you have like 1 year, and in 1 year you need to be done. So I mean, you cannot then start. I pick a chip, I modify an operating system, I try to look for the different safety libraries and so on, and then you're screwed. So I mean, you need to rely on something which is pre-integrated, which is already ready to use. You can put it on the board, and then it's running.
But in that context, you can also say it's like it's not the 1 year is not you only. I mean, it's you only, right? So there's other stuff. Your pre-integration can happen independent of that, right? So you don't have to phase that into the 1 year timeline.
Right. Exactly. It's pre-done for you. You can move fast. The whole idea is that you can move faster. And that also includes what you were talking about, Marcus, about, you don't have a board on everyone's desk like the old days. You have, virtual environments, virtual VDKs and virtual models, and that goes all the way up to ECU level and beyond, right? That's the future, and that's where it's moving to. So in parallel, when all this stuff's being done in developing the chip, they're actually developing virtual models for that same chip. And I've seen it. It's very hard. You have to keep them aligned. So every time the chip is being updated and improved, you have to update your virtual models. And now you have your software team, like what Marcus was saying, and we've done this at OEMs where they're developing the software the same time the chip's being developed, and it all comes together. You get silicon. We have customers come up within a couple of weeks. All their software is up and running silicon within the first 2 weeks. It's amazing, but it works. It works that way.
How do you make sure? It's a very, I'm curious. It's a very interesting topic. How do you make sure that the model and the silicon is actually identical? Because that would be the worst nightmare, right?
Exactly.
If everything passes simulation and then it's just like,
yeah. And I've seen it go wrong. I've seen it go wrong where they get out of sync. And that's a problem too. But
I would also say it's not identical. I mean, usually we get the virtual CPU models first in order to start porting the operating system in advance so that it's directly ready when the chip is produced. It's not in every case, but in some cases, we still, in the end, need to still check and modify some things because the model was not 100%.
You're saying still have to test on hardware later.
Oh yeah, yeah. It doesn't preclude
that was
hardware.
Just a joke. No, but in general, I'm curious. How do you actually? So Marcus, what you're saying is 100% is almost not feasible.
I mean, sometimes it's really working well, but I mean, it's not big changes, right? And it's nothing dramatical, but I think that it's really kept 100% identical.
Especially if you have time critical, things you want to test. This will be probably difficult. I mean,
time, real time, and
yes,
if you have race conditions or software race conditions or things like that potentially. Right?
Yeah. One of the things that came up, 1 year back when you did the SDV report, the pair of SDV reports, and I don't recall who actually told me this, but the thing is that depending on the time criticality and the development time that you may have, we choose different types of virtual models, let's say for your ECU development, right? And the thing is, the models that are really good, they take a lot of time.
Yeah, the high fidelity, level 4 type. There's different levels, right? There's different levels of virtualization.
Yeah, right. So if you have a very time critical developmental, calendar, that you might opt for a more rough cut model, and where you will get maybe 80% things will be 80% right. So you keep going, but then you might find more things downstream. Okay, more issues. I mean downstream as compared to, let's say, you have a very super perfect model, but which will take forever to in your cloud to run. So I think the developers have to make that kind of choice, and based on that, they will have to fix things downstream.
Exactly.
Somewhat.
I mean, you have to, for each task, you have to select the right type of model. I mean, when we are, for example, if an operating system is ported, actually, this is not something really time critical because, I mean, it's just about the register access, where the interrupts and so on. So here you can really work with a super accurate, like a register model from the hardware. If you're going higher models towards the application development, of course, this is absolute overkill, and then you're using other models. And within each level, I would say this is actually working pretty well. Mm-hmm. Of course, in the end, still some hardware test is needed. Of course, integration testing needs to be done.
Yeah, that's good.
I mean, if the chip is, provided by the semiconductors and designed, so to say, I mean, this is also somehow influencing the roadmap of the OEMs, right? I mean, how they can develop the car.
Can I jump on that, Fatih?
Yes, sure.
Because I had a similar thought. Because originally, OEM says we want to achieve this functionality. They go to the tier one. The tier one says, okay, I go out to the market and see what kind of chips are there, and I buy the one that can actually do roughly what we want to do, and then we start do the application on it, right? But now it seems more like the OEMs are saying, I need somebody to develop a certain chip with functionality for me, which wasn't the case before, right? Because semiconductor industry was just like developing cutting edge and say like, hey, suppliers to the OEMs, this is available, and pick your piece. Brian, I'm curious about this, especially we're talking about partnerships right now. So is the chip design actually much more driven by OEM?
Yeah, so
than it used to
that's
be?
a great point, right? Because traditionally, it was done. It was not done that way, and right now, we as a semiconductor vendor, you spend a lot of time with the OEM. You spend a lot of time deeply embedded with OEMs. at the security level, for example, or the safety level. There's a lot of things and requirements, and every OEM has different security requirements, for example. All that has to be thought up early. Again, this is why the semiconductor as the foundation is really, really important. If you don't get the foundation right and you can't meet those requirements, for example, just one thing towards the end of when I was doing this was the post-quantum crypto, right? We have OEMs that they demand that you have to be post-quantum crypto capable and that you can run those, because SDV is going to be in the field 15, 20 years, and definitely there's regulations by 2030 in some cases that you actually have to be have post-quantum crypto capabilities. So that's just an example, is that you need to be engaged early with the OEMs at this level. And it's interesting because I was talking to one of the semiconductor vendors, and they do a lot of analog, but they do some micros. And they said the only way they get the initial insight is by being on the processor side and working on the foundation with the OEM now, right? You don't get that from the analog side typically. It leads with these types of topics. And it's very important that the semiconductor vendors and the OEMs have these deep engagements at all levels of the need. But typically, like I said, safety, security, networking now is a key area, right? How they do the networking, the time-sensitive networking, because all of this is based on low latency, real-time responsiveness between zones. So networking is another area where a lot of work is done. When I was at the semiconductor, you'd be working with the networking groups and actually with and doing not just modeling, but with actual hardware, pre-hardware and such, and even FPGAs, actually modeling out all this stuff way ahead of time. And that is not the way it worked before, right? It was like, here's a chip, let's put it in a box and ship it out, right?
Yeah, here's the data sheet. You can do this and that with it.
Exactly. Totally.
And also AI, right? Now you also have to incorporate some kind of edge AI computational requirements. So that adds another element into your full platform design.
That's a good point. And there's so many different levels of AI, right? Because most people, when they think AI, they think Gen AI and such that they use AI with. But AI has been going on quite a while, actually, deep learning with neural networks within automotive, at least early on in the semiconductor companies even, right? And so there's tools that take these models, that optimize them, that do all the parsing and optimize them for the embedded space. And so this is a very important point. There's so many different applications of AI in the vehicle that a lot of people may not even be aware of. They see the visual stuff that they're aware of and the chat GPT types of stuff and interfacing with your infotainment. But you also know ADAS autonomous is using AI now for what they're doing. But even deeply within these cars, AI is being used for all kinds of things. Prognostics, that comes up on the latest surveys, if you see, is prognostics is really, really important. A lot of stuff's been going on a while. There's companies that are doing synthetic, virtual sensors that leverage, AI capabilities to do some really interesting things. So yeah, when you think of AI, there's multiple levels. So I see within the vehicle, there's MCUs now that have introduced AI, automotive MCUs. There's the central compute that are putting even higher performance level, that kind of think of it as a centralized AI hub. So we're seeing that now, AI hub, like AI services central to the vehicle, which is not necessarily the same AI that's even higher performance, which is for the infotainment that's doing Gen AI, and even the ADAS that's doing AI as part of AI in the loop as far as the driving process. So there's a hierarchy of AI, and all of those things have to be considered in the vehicle and the semiconductor selection. So.
Now, also actually software side, right? When you have multiple LLMs to deal with, you will need some sort of an additional software layer to kind of to orchestrate that. But no, that's a different conversation.
There's a whole thing around data. I was heavily involved in COVISA and BSS and leveraging that and all the data through the vehicle. How do you centralize the processing? And there's a lot of really interesting use cases, especially like even in Europe, I saw some regulations that could take advantage of this. There's a lot of interesting use cases that the SDV will, instead of this data being locked up within the vehicles, if you architect this right and have the right interfaces and can make the communications a lot of times where you need it low latency and seamless to the software and centralize it, you can start to do some really interesting data-based applications and then AI on top of it. So you can drive services or you can drive AI services directly from a centralized data place. And that's a big topic that I spend a lot of time on. And those are the kind of considerations you have to think about with the semiconductors, right? So I would say, safety, security, infrastructure, isolation, and how do I deal with data and AI? So I'm glad you brought that part up too. Yeah.
Yeah, Brian, I just wanted to ask, I mean, this collaboration process you just described between the semiconductors and the OEMs, do you think this will kind of change with technologies like chiplets, for example?
Yeah, so that's gonna be an interesting thing. All right, there's things like UCIe and standardization that's going on that is addressing more chiplets. I still think it's a way off. All right, the foundations of the technologies are coming out. It's going to be the level of standardization, and you have Renesas with the RCAR5, right? They have a couple of interfaces that can support chiplets today, for example. So we're starting to see that. We're starting to see chiplets, and I know people are heavily involved with automotive and chiplets. With IMEC, I believe, also, right?
Can you explain real quick chiplets for people who haven't heard about that?
Yeah, so think about, here's the issue today, right? We're keep pushing performance and memory and such, and we need to go smaller and smaller geometries, right? Every time you go to smaller geometry, you get an increase in performance, better power efficiency, but you don't always have to do that for everything in your chip. So I'd say there's at least two things there where a chiplet comes in. A chiplet is a small little semiconductor that can be mounted directly on silicon or put on the substrate of a board within a package. So you can have a chip. In fact, at XP, we had chips that already had 3 chiplets within them. So under the covers, chiplets were used. But what you can do now is those small little chiplets, you can create those very quickly within months instead of a year or two, right? And so say you need certain analog components, say you need different levels of flash memory or PCM memory or some type of exotic memory, or you need high voltage support, 48 volts. You won't create a 3 nanometer product with 48 volt support, for example, right? So where the chiplets come in, it allows you to build these more complete systems in a small area, but using small little die that connect to each other, either stack, like we see in the data center, they're stacking high bandwidth memory, HBM memory, right on top of the silicon, or in the case you can have one little PCB inside the chip where multiple little chiplets can allow you to customize that chip for every OEM differently. They may need different IOs, they may need different voltage, they may need a different AI processor, right? You could have and I think that's one of the things potential that like Renesas and all that, you have more ability to customize.
And they may need different types of boxes. Okay, maybe you have some packaging constraints depending on the OEM. Maybe that might also drive some of the requirements when you are talking about stacking up your chiplets.
Yeah, thermal, right? Thermal comes into play here because now you have more thermal considerations potentially. Although a lot of things you stack and such on this world, not like the data center, is not as maybe not as power intensive. It's just customized IOs or something like that, maybe. But yeah, power is a big consideration, which leads to packaging, which leads to, do I have airflow, or is this thing where I have to put in the center of the vehicle and actually have it liquid cooled, which we see in some OEMs are doing. They're putting everything in one. They're sandwiching infotainment and ADAS with everything else, and in between it, they have liquid cooling going on. So that's happening too.
Yeah, and Marcus, mentioned, I think that opened up some more additional thoughts in my mind. You said, hey, how chiplets can actually redefine the nature of the specific nature of the relationship between the key players. In my mind, also the software and the hardware, semiconductor people and the big software companies, they are forming relationship, and based on specific software technology they want to kind of incorporate, right? One example I saw, I don't know when, maybe a month or so back, Google and Qualcomm, they have formed a partnership to basically incorporate the Google's new what they call SDV Android Automotive OS or something. Yeah. So how they're going to integrate that into Qualcomm's platform, digital chassis platform, right? So there's a completely new type of relationship now with this mega software company, Google on one side, and this mega semiconductor company or Qualcomm on the other side. And that's a very completely new type of partnerships that we are seeing in the automotive space.
Yeah, but again,
go ahead, Marcus. Go ahead.
No, I just want to say that this is still the level of integration. This is because I mean, if you're looking at NVIDIA or Qualcomm, I mean, there's so much that even our software is pre-integrated somewhere there. So this is also a partnership we're doing. But because in the end, it's the expectation is you just purchase one of their systems, and the ADAS is more or less running default use cases out of the box,
Yeah.
and you get the cameras from them. I mean, this you only achieve by doing this outside of a project, doing and more or less everything what you do outside of a project is a partnership, because it's not a direct contracting within one project. And therefore this is needed, otherwise you can never really meet these types of timelines.
Yeah.
Okay, but if I listen to you guys, I mean, I have the feeling that the game changed. It shifts. I mean, the game shifts to more the big IT company, the big semiconductors. Where's the OEM actually? I mean, now this is. I mean, the OEMs don't have any leading position anymore, because the semiconductors and its big IT companies like Google or dictating actually what should happen. And I mean, how OEMs can work in this, very difficult environment.
There's an aspect of that, but you also have to look what part of the vehicle, right? Because infotainment and ADAS are very different than other parts of the vehicle. And listening, like Ford publicly talked about some of this too, about how they work with a lot of their partners. And one of the big, I would say, friction points right now that people have to get past, and these software companies are going to have to deal with, is that the OEM actually at the high level have to in an SDV want to take control of the overall. And the big issue that was brought up by Ford was that when they have an issue that needs to be fixed, they need to do it in 2 to 4 hours, and they can do it. They have people that can do it, but they need access to software. So this is where the friction is going to be with the tier 1, especially, right? And they said working with even engineering services companies, they get quotes for 6 months turnaround. That's unacceptable, right? You can't compete with China and other places with a 6-month delay to fix a problem. So this is an interesting dynamic that there needs to be a lot of really close collaboration there. They're going to want more access to modify code, and I know this is going to be a big issue for people because they don't want to open up their software. But if they cannot support the OEM's needs to be successful, that's something this has to be worked out somehow. But that's what they're pushing for. They're pushing that I need access to your software. We're not going to use it. We're not taking IP. It's just to modify, be able to update as we need to keep this platform safe, secure, and to meet the consumer's expectations. And if they can't do that, they'll have to work with other software providers. So I think there's a big disruption coming based on what I heard last week from them.
Yeah, one of the big discussions around there is liability. Obviously, if I give you the software and you modify it and it doesn't work as described, right? Is it my fault or your fault? But I'm fully on board with that, and I'm for years now vouching. It's like I mean, software. The more people look at software, the better the software usually gets. It's not like keep it secret and then. If you don't see my bug, the bug's not there. The bug's still there, right?
Yeah.
So
that was a point. Actually, that was a point that Ford made. They said, "Look, our customers or us will find us internally. We'll help fix it. We'll work with you or fix it, and then you will get that back, right? It's not like they would get it back and said all your customers will benefit from the same thing. So they brought that as one of those advantages, exactly what you said there. So,
and it's very interesting. It's going to be very interesting to observe now that pretty much humans are not going to write any software anymore anyway, but there's some generative AI taking care for that. At one point, is that really intellectual property? I don't think so.
It will depend on how the individual lawyers frame the relationship.
Yeah, they have to get used to AI as well. But the thing is, if I'm giving the three of you a specification to write software and you all put it into ChatGPT and give me the output back, is that your intellectual property?
I think at the moment, yes.
Yeah, because you're delivering it.
So there's two. Marcus says two angles there: the legal angle and the common sense angle.
Yeah. True.
Yeah, I think that is also at the one of the foundational conversation around open source, because like you said, Florian, a code gets better when multiple players look at it. But at the same time, everybody wants a single point contact who said that I'm taking the reliability. I'm also demanding some extra money for that. And correct. I will quote unquote maintain that software 5 years, 6 years, 8, 10 years from now. And I think that's the conversation why would the OEMs are hesitant to go into the open source mode, because they said, hey, I'm used to buying products, be it a physical product or a software product, from somebody who has all the
warranty on top.
Yeah, they took control of everything.
Yes. And if it fails, I can make that person reliable and sort of share the responsibility, right? So in an open source, how will that be framed? I'm not saying it's possible or not possible. I think the open source community also have to figure out a way to kind of deal with that, so that you have that benefit of this multiple participants influencing the outcome of the software, but also at the same time some structure that picks the responsibility for maintaining and making it productionize it and maintain it for the long term.
Yeah, and you must not mistake open source for the Wild West, right? So sure, there are some projects which are the Wild West.
That's the point.
Automotive open source, there's some very well governed. I mean, you look at AutoWare or Eclipse Foundation or something like this. There is some governance there, but of course you also have. You're right when you're pointing out somebody has to take the responsibility, and that's usually what happens when you branch it out into commercialization.
That's definitely a key thing that has to be addressed in this new model, because I see it has to be changed. It has to change, and you're hitting on the right points that have to be addressed in that process.
Yeah, and I think organizations like Eclipse are very aware of that. So like you say, their governance model is actually trying to achieve the same thing, so that I do have the developmental cycle, but then I have a commercialization cycle where I would have a single point, whoever that be, for the software itself. We'll
Marcus,
see how that goes.
Marcus, you raised a couple of eyebrows when we talk about that, so I'm curious about your angle.
I mean, the open source topic is always a little bit difficult, right? I mean, the main ideas, and I fully understand this. I think the biggest problem right now is, and we're also looking into many types of open source. We're contributing to open source even stuff of our products, but the business model is kind of the problem. And I mean, the answer even for the liability is typically this is what is called a maintainer. So typically the maintainer takes over this role of the person who takes over also the liability by giving some guarantees of or like an SLA when to fix and how to fix and so on. The problem is, in most cases, then these types of fixes needs to be published again, and he cannot really create value by this, because even then some other person can just take it and sell it again to somebody else. So this is in most cases just a business model problem, and until this is not really solved, in most cases this works only if the business case doesn't rely on the software itself. So for example, take Android. Android is open source. Everyone's or most phone providers are using Android in their phones, and it's only it's only working because Google is making most of the money with the App Store and the infrastructure later on. So the software is just a free giveaway to lock them into their ecosystem of stores and online services. Yeah. So these types of models work, but these models don't exist yet in automotive. So therefore, I think it's not really a huge open source system available at the moment.
What needs to change, Marcus, actually, to have such business models? I mean, I think this is the future. I mean, the smartphone sector shows us how, we should go also in the automotive. And I think this is the future, in my opinion. And
you got to draw the line between, and Brian made that very clear at the beginning, between safety and non-safety applications, right? So safety critical, non-safety critical applications. So one thing is your screen that entertains you in the car, which obviously Google is working on Android Auto, something in that direction. But then obviously you also have like your powertrain or safety restraint control systems and stuff like this. And I think it's very different. And the smartphones don't offer us any great approach into those systems.
Yeah.
No, I mean, the business model is clear. I mean, I think the OEMs will make money after sale or post sale, so to say, with all this ecosystem, also apps and whatever systems, feature as a service and whatever things. I mean, just selling the car is not anymore enough for the business. I mean, you need to extend the business after the sales.
If you do it right, you do that, right? You don't have to, but if you want to sell cars in the first world market, you will have to, yes.
Yeah.
One thing, Florian's, to expand on Florian's this comment about safety, I think one thing we can probably safely, not to make a fun of it, conclude that because of the safety and security involved in an automotive software, maybe we cannot just have as many updates and versions of it. There has to be some level of stability. I mean, obviously, the idea behind SDV is that we will be changing on a periodic basis, but the frequency of the change, whether it's an open source or a closed source software, that frequency of change has to be somewhat less than what we see in the smartphone space.
Oh, definitely.
I don't know. What do you guys think?
I think so. I mean, I see some of a hybrid where people are thinking more of a quarterly update, right? But then if there's some incremental critical things they would do, that they could implement those somewhere in between, but more quarterly. I'm interested in your views on this too, everyone. How do you see these the periodicity of the updates? What do we see?
So we actually, at my time at Tesla, we looked into that with the voice of the customer. So we realized that there's what we call the update fatigue. So if you update too often, the customer gets the feeling they bought a lesser product. So the sweet spot we found out in the discussion, and again, Tesla customers are more open for change than other car customers. But you have the 3 months period for quote unquote standard customers, and then we offered also a 6 weeks period for the more interested early adoption or however you want to call it, first user. But that is what we found out. So at one point when we totally cranked the machine as much as we could, which is like weekly updates, we got that feedback very straight and clear. It's like, if you send me an update every week, that gives me the feeling there's something wrong.
Yeah. So that quarterly, I think you're saying the quarterly update may be the sweet spot.
Also for me, as a customer, I got to say, I'd like to see quarterly updates to my vehicle. And we're not talking about empty updates, right? Please. So if any OEMs are listening, send me something that actually has user-facing improvement.
New value.
Yes, new value added, right? So yeah, quarterly for new or like modern OEMs. I don't know if that's the right term, but for more traditional OEMs, maybe 6 months. But that also depends maybe by model, not only by brand.
Yeah.
Hey, I just to and Fatih, you can decide if that's the right topic for conversation here. But talking about partnerships, I'm also seeing something interesting where we are not just talking about hardware or software partnership, but we are talking more about end-to-end partnership, which includes and maybe this goes to this shift left and shift right conversation we had last time, I think, where the partnership is all about not just about hardware or software, but about, let's say, testing, validation, and all those simulation and everything. So for example, NVIDIA's relationship with GM is not just about their drive, the fundamental drive platform, but it also includes their Omniverse, the simulation platform, their robotics for final manufacturing platform. So they're really looking at what it seems like from outside is more of an end-to-end partnership to not just develop the software-defined architecture, but also build it, validate it, and take it to deployment. Any comments on that? That changing nature of, rather than expansion of the scope of partnerships within the SDV model.
Yeah, I think this is true, and I mean, this is, for example, exactly the aim also we are targeting, because in the end it should be as simple as possible, and as if you pre-integrate as much as possible, in the end it's getting more simple for the customer. So our vision, for example, is, and this is also partly achieved already, you more or less just log into a web environment where all your software development tools are already running, the virtual test environment. You can even hook like Hill hardware tests into this environment, and you can open up parts of this even for not only for the OEM, but even for any third party who wants to develop like a software component for any specific vehicle. So and in this environment, of course, all the different ECUs, test benches, code checking, AI tools, everything is already in there. And I think this is the final goal everyone at the moment tries to achieve, because this really makes the SDV like a reality. Just log in, write the app, click on deploy, and it's there.
Yeah.
But one prerequisite for this is also iterative development, right? So if you're going and like you're changing entire architecture every 3 to 6 months, which some OEMs in Central Europe have done in the last few years, you have a real hard time to. I didn't say anything. So you have a real hard time to get like a pre-integrated ecosystem ready for iterative improvements.
Yes.
And that's why,
the whole story is always behind you. If you are not ready for small increments, directly roll it out, quick testing, quick improvements. This is absolute necessity.
Yeah, and that's why back to semiconductors, right? It's not just a hardware choice; it's an ecosystem choice of what beyond the chip, right? There's so much complexity involved, and how far can you go? And a lot of times, maybe the chip that maybe looks the best on paper may not be the right chip because it doesn't have all the other ecosystem and enablement around it that gets you where you need to go in the time period you need to go, right? There's so much that you have to look at there.
I think that's a really great statement. We're not yet at the very end, but I think if we were at the end, that's a great statement. It's like keep the entire picture, right? It's like the same when you buy a new car, you find the color you love, but in the end you figure out you actually needed a station wagon and you bought a convertible because you like the color so much, right? So you need to see the bigger picture and the whole thing you want to do, especially as Marcus and Brian just said.
One thing
I also thought that could be one of our key takeaways today, that when you talk about partnership, it's not a very specific focused partnership, but it should probably have implications for the entire ecosystem of your developmental ecosystem, basically.
Yeah. One thing I'll mention related to kind of expanding out beyond, like you're getting at higher levels, because OEMs are looking for as much. I mean, they're very open, and I go back to the Ford one. They're very open about that they need these partners. They're looking for new partners. They need people to expand their capabilities and to move faster. They need that, and that's an industry. I think that's true for most companies. But one interesting thing, just from my SDVerse experience, because like I said, I'm an advisor for SDVerse, which is the software marketplace. But you're now seeing even extension from the traditional everything from libraries and drivers all the way to full stacks, to test tools, to validation, to services, everything you need, right? There's probably 100 different categories of products. But now we're even seeing that the OEMs are looking for software within their manufacturing side, right? That they want to be, process on their automation side and their data and analytics side, and how does this all tie into the manufacturing process? And we don't often talk about, I would say, the manufacturing side, the implications of SDV to manufacturing, but there's some significant value to the manufacturing process of an SDV versus vehicles today. And so I just want to bring that as a note, that we're seeing kind of that trend that OEMs are looking for even more software than you were even thinking of. They want more, right? And that can extend even into the manufacturing area, whether it's quality control or data analytics or whatever, to make manufacturing of SDVs more efficient.
Cool. I mean, we're almost at the end of the time. I mean, I think we need also a session, Brian, about this SDV words and the idea behind what it is. I mean, the whole ecosystem. I think this is not really known. I think we need a separate discussion about that. Probably in future, we can plan something. I mean, we're at the end. Thanks for joining. Do you want to? Some final words before we close? If you guys want, feel free.
Who wants to start?
Marcus?
Always I need to start. That's not fair.
Some final words,
I think we had now two really interesting sessions about partnerships, and I think the integration aspect on so many different levels for the ADAS system, for the chip level, for the software, for the middleware, for the OEMs. I think this became clear, and I think it really set the stage for more partnerships in the future. We will see more partnerships, and this is what's coming, and this is what we're looking for. And therefore, it's such a nice time for software in automotive. We will see more partnerships, and that's great.
Yeah, and what's really changed is, partners before were sourcing decisions, right? Partners now are collaborative, right? They're part of the core architecture and how you're going to approach your SDV. and how you're going to implement it, right? It has to be thought out a lot up front. It's not just, it's interesting because I'm seeing that transition too through SDVerse, where procurement people traditionally, think about how SDV is impacting procurement people. I even heard actually from one of the software companies that the procurement people were asking what is the weight of your product, right? The thinking is hardware still. They don't think of software. The procurement is not always optimized. They're not optimized. This is all new. They're all learning, right? And so this is not a sourcing decision. Sourcing helps find it, but you have to, this partnerships and collaboration related to those is an architectural fundamental platform decision that will drive the sourcing and procurement. It's not just a sourcing decision. I think that's a key thing here that's different with the SDVs. So.
Right. And I would say, we talked today, our discussion was largely from a kind of a OEM perspective, but fact of the matter is the entire, what used to be supply chain, they are basically, as they are trying to struggle their way into SDV, they are forming their own partnerships. For example, Sonatas is a software company, and I'm not trying to promote any company when I mention a name, but Sonatas recently formed a partnership with Schaeffler, and I mentioned Schaeffler because they impressed me, again, not promoting them. They impressed me because they used to be a very traditional old school vehicle chassis component or system maker, right? They basically, moved their way up into software-defined vehicles. So the partnership that I mentioned earlier is about Sonata software running in their control systems, okay? And again, to enable, it's like an edge software running into the control system to enable a full SDV chassis, right? So that was an interesting, it's a small but interesting example that there are partnerships happening. And by partnership, I mean in the new paradigm, which is less transactional, more strategic. Like I think Brian, you mentioned that it has to be a lot more strategic. So we are seeing those less transactional and more strategic partnerships happening at various parts of this ecosystem that we are talking about.
Exactly. That's a good way to summarize that up. Exactly. It's more strategic and not a tactical procurement decision anymore. Yeah.
Okay. Thanks for your final words. I mean, Florian, I don't know if you want to say something.
I think something that came to my mind as a closing statement, and it's a little motivated by what Partha said a little earlier. It's like vertical integration is a term a lot of people are using for in one company, but maybe we have to vertically integrate a little bit with different companies between suppliers and users, not to call them OEM at this point. So not to build up those artificial walls, and that came from Partha's comment about the testing and shift together, I would call it now. But yeah, let's integrate vertically together throughout the industry rather than only within one company, because we've seen that struggling.
And that early on, they were saying that this industry cannot survive doing it that way, without that, because everyone can't reinvent the wheel and spend tens of billions of dollars to do it. There has to be some of that together, and that's where the value is going to be in the industry, I think.
Yeah. I thank you so much again for joining. This conversation was really very, very interesting, and I think we can talk many, many hours about that. But yeah, time is over. Thanks for joining, and let's keep the conversation going in the next episodes. See you then. Bye.
Yeah, good to see all of you. Bye-bye.